Continuing on, this is 1.6 other types of equations. Goal is to solve over the complex numbers. Over the complex numbers means our solutions could be real and or imaginary. So we, instead of writing no solution when we score a negative, we actually give a solution. So most of these equations are going to be the same as what you've seen. Some near the end are a little more challenging. And the last example that we have is the opposite of solving a quadratic, but given the roots, find the actual quadratic. So first, all of these are going to be solved for x over the complex numbers, which means our solutions can be imaginary. If we note to the sub, if you need to pause at any time because I'm going too fast, that's fine. And rewind if necessary. For these, we have 4 terms. To solve, we have to group. We do a GCF. This is nothing different than what we've done before as far as grouping to solve. And now we have x squared plus 3 times x plus 2 equals 0. That step, you can think of it as x squared plus 3 is being multiplied by x plus 2, or you GCF and x plus 2. 0 product property. We set both equal to 0. For the second one's very easy to see. X equals negative 2. The first one, we have x squared equals negative 3 when we square root instead of writing no solution. First off, we square root, so we get a plus or minus. Root negative 3 breaks down into root 3i. Second problem, the square root of x minus 10 minus 4 equals 0. The minus 4 note is outside of the root. So this is a little different. We have a square root within an equation, but we know how to undo, quote unquote, undo a square root. We square it. Excuse me. So first, in order to get a root, get rid of a root, we have to get it by itself. We add 4 to both sides. Instead of getting rid of a square by square rooting, we square to get rid of a square root. Those cancel. We're left with the radicand. Per square gives us 16. Not plus or minus 16, just 16. Add over 10 gives us 26. For the third problem, we have the cube root now of 3x plus 1 minus 5 equals 0. Same idea. First, let's get the root term by itself. And now instead of square rooting, we now are squaring to get rid of the square root. We cube to get rid of the cube root. Those cancel. We're left with 3x plus 1 equals 125. 3x equals subtract over 1, divide by 3, gives us 124 over 3. 4, a little more challenging. If you note, that's the bell, so I'm trying to do this as quickly yet with best explanation as possible. Here to get when we have 2 roots by subtraction, addition, and so on. Here's subtraction and addition. If we square both sides, we're going to be foiling. That's going to get nasty on the left-hand side. So another thing we could do is move over one of the terms. Root 2x plus 3. I added all that over just like it was a variable. Now if we square, we still get a binomial, but or a binomial square, but that binomial squared only has 1 radical. Similar, and also over on the left-hand side, when we square, we get rid of this radical. So 2 squared, note you're squaring both, is 4. When we square root x plus 1, we're left with just x plus 1. Over here, we're left with root 2x plus 3 plus 1 squared, which means it times itself, plus 1. Okay, so we just got to be careful with our math here. I'm giving myself some room. The first would be root 2x plus 3 times root 2x plus 3. Just like root 6 times root 6 equals 6, because that's root 36, when we multiply two radicals with the same radicand, we end up getting just the radicand. Once again, root 6 times root 6 equals 6. Then we do 2 root 3 times 1 gives us root 2x plus 3. We do that again, and we get root 2x plus 3. And then 1 times 1 gives us 1. Okay, let's try simplifying. Well, I have the 4 distributed over here. I have 2x plus 3. Nothing to do there other than get rid of the parentheses since we're all in terms of addition or subtraction. I have one root 2x plus 3 plus one of them gives us two of them. Remember, when we add, we think of them like variables, plus 1. And now let's hope about we get the radical by itself. Now we only have one radical, just like we had back in this example, or this one, when we had radicals by themselves, we can square to get rid of them. So I'm going to subtract the 2x term over. That will give us 2x. 3 plus 1 gives us 4, which cancels with that. And over here we have 2 root 2x plus 3. Now, just like we had before, but a little more challenging because we have an x on the left-hand side, to get rid of that radical, we can square it. Note, actually, I apologize. Before we do that, let's go ahead and divide by 2 to get the radical completely by itself. So if we divide by 2, those cancel, those incidentally cancel. We end up getting x equals root 2x plus 3. Now if we square, we can get rid of the radical. We get x squared equals 2x plus 3. Inconveniently, but bearable, now we have a quadratic. How do we solve quadratics? Move everything to one side, MAG. What multiplies to be negative 3 and adds to be negative 2? That would be x minus 3, x plus 1 equals 0. We would get x equals 3 and negative 1. Now, just like with rational equations, we have to eyeball check. Eyeball check means don't plug in to make sure that works. We make sure that it doesn't make a radical negative, because we can't square root a negative in terms of real numbers. Remember, if one side equals the other, then, or if we plug in, we can't have imaginary numbers added to real numbers, for instance, to get real numbers. So in any case, if x equals 3, if I plug back in, 3 does not make either of those a negative number, so we're fine. So 3 is good. But negative 1, if you look, negative 1 will make that negative. Negative 1 makes that radical negative, and therefore that is not a solution. Lastly, we have problem, find a quadratic with the given roots. If I give given the roots 3 and 5, remember, roots are the same thing as solutions or x-intercepts. This is going backwards from when we factor and solve. So that's the same as x equals 3 or x equals 5 are your roots. Well, if I move that over, think just going backwards, if I have x minus 3 equals 0 and x minus 5 equals 0, that came from the factorization of a quadratic, x minus 3 times x minus 5 equals 0. And lastly, they want it in standard form, so we distribute x squared minus 8x plus 15. Went a little fast than I would prefer, but hopefully that lesson will give you a good fighting chance at the homework, and then we will work on the continuing on with this on Thursday as well as Wednesday.